Hello GCC students. We are now going to look at a redox reaction. My name is Dr. Kim. Redox reactions are a combination of reduction and oxidation, thus the name redox. In order to understand redox reactions, we need to know what reduction and oxidation stand for. Oxidation is when the charge of one of the atoms in a reaction increases or goes up. You can remember this because oxidation starts with a vowel and so does up. So ox is up is oxidation. Reduction is when the charge goes down. This makes sense because if you're at a store and they've had a price reduction, did the price go up or down? Of course, when you have a sale and you've reduced the prices, it goes down. So reduction makes sense that the charge will go down because it's reduced. We also have agents when we talk about redox reactions. Now, agents are helpers. Think about a travel agent. Does the travel agent travel? No. The travel agent helps someone else travel. Well, that's what the agents are. If you are oxidized, then you're actually called the reducing agent because someone else was reduced and you helped them. If you were reduced, you are called the oxidizing agent because you helped someone else get oxidized while you were reduced. See, they go hand in hand. You can't have one without the other. If something is oxidized, something else has to be reduced. And so they help each other. Here's a typical redox reaction. Typically, you are asked 4 questions. What is oxidized? What is reduced? What is the oxidizing agent? What is the reducing agent? You can be asked any 4 of these questions, even on a multiple choice test. So we need to be able to answer them. Now, if we look back at our definitions of oxidation and reduction, we were looking at charges going up or down. So we need to go through and label the charges in this reaction. What is the charge of magnesium when it's in its solid elemental state? Well, it's neutral because it's made up of atoms. So, what's the charge of an atom when it's neutral? 0. The charge of magnesium in its elemental state is 0. Now we have zinc combined with Br in a compound. So it's not neutral anymore. We've had some electrons gained and lost here. So we're looking at charges in an ionic compound. What's the charge of zinc? Well, let's look at our table. I hope you remember that zinc and cadmium, these two, are a +2 charge when they're in an ionic compound. So Zn is +2. What about Br? Well, it's a halogen. It's in the halogen column. And in an ionic compound, they have a charge of -1. Now, on the product side, we have zinc solid. So it's in its elemental state. What's the charge on an element in its elemental naturally occurring state? You're right, it's 0. And then we have magnesium bromide. Magnesium, where is it in the table? If you said alkaline earth metals, you are correct. Column 2. What's the charge of column 2? +2. And Br we've already looked up as a halogen. It is -1. So let's look at the metals and see if their charges went up or down. So I'm going to draw a line connecting magnesium to magnesium and zinc to zinc. Let's look first at magnesium. The charge went from 0 to a +2. Is that going up or down? It's going up. What did we say up is? You're correct if you said oxidation. Now let's look at the zinc. It went from a +2 to 0. Is that up or down? If you said down, you are correct. And what was down? Correct. Reduction. That is when it goes down. So what is oxidized? Well, magnesium solid was oxidized. Its charge went up. What was reduced? Well, the zinc in the zinc bromide's charge went from 2 down to 0. So we're going to answer with the whole compound in Chem 130, ZnBr2, aqueous, was reduced. Now, let's see if you remember about the agents. Remember, the reducing agent is whatever's oxidized. So the reducing agent is what is oxidized, which was magnesium solid. And the oxidizing agent was whatever was reduced. So the oxidizing agent is zinc bromide, aqueous. And I believe we've answered our 4 questions. So now you know how to do a redox reaction. Good luck!